Welcome to This Explainer. Today, we're diving into a genuinely fascinating intersection, the space where the sci-fi theory of AI basically building itself crashes right into the bureaucratic reality of how frontier labs are actually trying to govern that future. We're going to be drawing on a deeply insightful technical report from Anthropic, alongside a rigorous Safer AI audit of OpenAI's preparedness framework to figure out exactly where we stand on the precipice of advanced artificial intelligence. Here is our roadmap for today. We're going to start by defining the self-improving AI, look at 3 potential futures of AI, tackle how we manage frontier risks, dig into the mechanics of indicators, controls, and thresholds, and finally, wrap up with practical steps for building safe AI systems right now. All right, let's jump right into part 1, the self-improving AI, and specifically defining RSI. So to really grasp what fundamentally changes the game here, we have to define recursive self-improvement, or RSI. As you can see, it's an AI system's ability to make meaningful, compounding improvements to its own capabilities and training processes. It's absolutely crucial to understand that RSI isn't just a machine getting a little smarter because humans tweaked the code. It is the AI itself actively driving its own compounding capability loop. Every single improvement it makes enables further and faster improvements. Think about it like this. We are moving from a world where humans are the ones pushing the wheel to a world where the AI puts its hands on the wheel right alongside us. Standard AI development relies on us to design the training runs, curate the data, and evaluate the outputs. But under RSI, the AI system actively participates in or even completely drives those architectural and capability gains. It's a huge paradigm shift. Moving on to Section 2, the 3 futures of AI, looking specifically at Anthropic's scenarios. Anthropic actually lays out a spectrum of possibilities for our future. First, there's the plateau, where progress remains incremental and entirely human-driven. At the other extreme, there's full RSI, where AI operates with minimal human intervention. But Anthropic considers Step 2, human-guided acceleration, to be our most likely near-term reality. In this scenario, AI meaningfully assists research, but humans remain firmly in the decision loop. And for you builders out there, this is vital. If top-tier researchers need a human in the loop for their models, you definitely need one for your own AI agents today. But there is a pretty stark warning in the report that we need to talk about. Anthropic explicitly states that our current, somewhat slower-moving alignment mechanisms simply might not hold up under the immense pressure of self-directed AI improvement. If we do reach full RSI, institutional frameworks for governance absolutely must exist before the systems do. We literally cannot build the safety nets after the fact when a system is improving itself at an exponential rate. Which brings us to Section 3, managing frontier AI risks, specifically looking at OpenAI's framework. So, do those safety nets actually exist yet? Well, to find out, we can turn to a really comprehensive Safer AI audit of OpenAI's preparedness framework. OpenAI separates threats into 2 buckets: immediate, measurable threats, and theoretical ones. Tracked categories include biological and chemical threats, cybersecurity, and, very notably, AI self-improvement. Research categories deal with things like long-range autonomy, nuclear risks, and undermining safeguards. By shifting AI self-improvement into a fully tracked category, OpenAI is clearly signaling that this requires active, immediate intervention if specific thresholds are crossed. Now, why are we tracking these so closely? Just take a look at how OpenAI defines the stakes. They define severe harm as the death or grave injury of thousands of people, or hundreds of billions of dollars of economic damage. These are literal world-altering stakes, which makes it absolutely critical to measure exactly how they plan to keep AI capabilities safely below this devastating threshold. We're not just talking about software bugs here, we're talking about global security. Let's get into Section 4, indicators, controls, and thresholds. This is all about measuring that risk. This is where those dizzying sci-fi concepts crash straight into the bureaucratic reality of risk management. To manage risks, you need metrics. The first is a key risk indicator, or KRI. This is a metric used to measure the level of risk in a system. I want you to think of a KRI as the speedometer on your car, telling you exactly how fast the AI is accelerating toward those high capability levels that could trigger the severe harms we just talked about. On the flip side, we have the Key Control Indicator, or KCI. This metric is used to measure the effectiveness of your safety controls and safeguards. So if the KRI is your speedometer, the KCIs are your brakes. The real tension here lies in whether these brakes are defined clearly enough and are strong enough to actually stop the car if the speedometer suddenly maxes out. So, what happened when an independent auditor like Safer AI actually looked at the mechanics of OpenAI's brakes? Well, the scores were surprisingly low. In their rigorous audit, OpenAI scored just 33% on risk identification, 28% on risk analysis, and 38% on risk treatment. For a company operating at the absolute frontier of technology, these numbers suggest a major gap between theory and practice and show that their current safety frameworks still have quite a long way to go. That 28% in risk analysis really comes down to what's called the vague threshold problem. OpenAI's framework dictates that safeguards must sufficiently minimize risks. But what does that actually mean? The definitions of when to apply the brakes are highly subjective rather than concrete mathematical thresholds. In fact, their quantitative deployment KCI scored a mere 10% in the audit. When the stakes involve potential global catastrophes, vague terms like sufficiently just leave way too much room for error. There's also the discovery of a pretty concerning loophole. The Safer AI audit points out that OpenAI's framework includes a marginal risk clause. This actually permits them to deploy models with weaker safeguards if competitor models are assessed to be doing the same. So OpenAI's risk tolerance is somewhat contingent on their competitors' choices, essentially creating a race to the bottom loophole in the very framework designed to protect us all. Finally, Section 5, Building Safe AI Systems. Let's look at some practical takeaways. We need to bring these massive lab-level governance policies down to earth for developers who are building things right now. Anthropic's report outlines what they call minimal footprint engineering principles. First, you need to define clear scope boundaries. Second, you must build explicit human confirmation steps for any high-consequence actions. Third, you have to log everything, inputs, outputs, and intermediate reasoning. And lastly, design for graceful degradation, meaning if the AI isn't sure, it fails safely. Whether you're at a frontier lab or just building a simple email assistant, these are fundamental engineering requirements. Because model capabilities are going to shift incredibly fast in this era of human-guided acceleration, your survival as a builder depends entirely on creating adaptable workflows. You've got to build modular logic so you can easily swap out models as they upgrade. You must implement checkpoints where humans hold the ultimate key, and you need to instrument interpretability. You must always know exactly why the model took a specific action. You just have to be ready to pivot the second the technology leaps forward. Which brings us to the ultimate question. As we accelerate toward full recursive self-improvement, will our bureaucratic safety framework scale fast enough to catch up, or will the technology outpace the very brakes we are trying to invent? I'm going to leave you with that thought to ponder, because the gap between the self-improving AI we are building and the granular frameworks governing it is undeniably the most important space to watch in the coming years. Thanks for joining us for this explainer. Stay curious and keep learning.